Okay, class. So everyone is here? Okay. Good. 5 of you, yeah. Okay, so let's restart. Can see the PowerPoint? Anybody? Okay, good. Okay, class. So, so let's wrap up this topic. So, the day we did done about the law of reflection. The intensity will reflected partially, transmitted partially. Then we introduce a new quantity called acoustic impedance. Okay, acoustic impedance is the product of speed of sound and the density of the material. So acoustic impedance is very important to determine how much going to be reflected. So all dependent to intensity reflection coefficient. Okay, IR over I. Okay. So if the acoustic impedance is both medium is about the same, majority will be transmitted. If there is a big difference, it's about the same, majority will be transmitted. Okay, if there is a big difference, then alpha going to be very small. So big difference, alpha will be very big. Sorry, alpha will be very big. So majority will be reflected. Okay, so this is all we done. So tell you about why you need to use a gel. So then we talk about absorption. When you pass through the medium, absorption happens. Okay, then we did some questions. Okay, now today we're going to talk about the qualitative measurement, significance of absorption. Okay, ultrasound absorbs to the tissue absorbs the ultrasound. So what is the consequence of absorbing the ultrasound? Okay, there are two important considerations. First, when it absorbs ultrasound, that means it absorbs energy of the ultrasound. It might heat the tissue, okay, to a dangerous temperature. Okay, the ultrasound energy might heat the tissue to sometimes to the dangerous temperature. Okay, so we need to limit the limiting factor for the depth penetration of the beam. Okay, then another thing is that's the first problem. Absorption causes temperature of the tissue can be raised at a dangerous level. Not common, very rare, but sometimes do. If you prolong using the ultrasound, but very long. Another problem of what absorption give a negative effect is limiting the depth it can penetrate. Okay. So like for example, bone. Okay, bone absorbs most of the ultrasound. Okay, bone the coefficient of absorption is very high for bone. So let's say on a layer, let's say someone is break their leg. Okay, so the bone in the leg. Okay, so when they use ultrasound, pointless to check the bone because ultrasound will go into the bone. What happened? That's it. A majority will be absorbed. So no reflection happened. No reflection happened. At the same time, reflection will happen, but after passes the bone, that's it. No reflection happened. Okay. So what happened? They can't scan bone. Ultrasound is a waste if you want to scan bone. Okay. Why? Because it absorbs most. So if you have a bone, after that you can't go deeper. For example, stomach layer, you want to put the you want to put the transducer on top on the tummy. Okay. So when the ultrasound want to detect deep inside organs, such like maybe kidney, your kidney. Okay. Kidney normally located at the back, close to the back. So let's say the doctor want to move from the front to investigate about the kidney. He can't because too deep. If in between got some tissue which can has a great absorption coefficient. What happened? It absorbs most of the ultrasound. So you can't. By the time it reach the kidney, there is no ultrasound anymore. So absorption affects the penetration of the beam. Okay, greater the absorption, more smaller the penetration. Okay, Yeah, so this is the significance of absorption. Penetration is a bad for us because never allow it to penetrate. Energy, sometimes it can damage the tissue, but sometimes there is a side benefit. Sometimes the physiotherapy use ultrasound to recover from the sprain joints by giving a little heat produced by the sound ultrasound. Okay. The heating effect caused by the ultrasound of suitable frequency is in fact used by physiotherapy to assist recovery from the sprain joint. Okay, there's a side benefit. Okay, but you can't go deep is one setback actually, because of absorption. Okay, the factor affecting absorption. What causes the tissue absorb more? The first factor is the density of the tissue. The higher the density, the more absorption. So therefore, fluid, fat is how the increasing order absorption level. The bone and calcification going to absorb the most. Okay. Next factor is depend to the frequency of the ultrasound beam. The higher the frequency, the more absorption. Okay. You see, the doctor when use ultrasound, he can adjust the frequency of the ultrasound. If he want, remember, if the frequency is increased, I tell you, okay, sorry. Okay, let's say the doctor want to penetrate the body. Okay, they're checking the kidney. Okay, they want to check the stone, kidney stone. Okay, they want to check the kidney stone. There is a stone here. Okay, so if they put ultrasound with a very low frequency, so V equals to F lambda. Speed is constant. Very low frequency, wavelength going to be big. So the wave going to be a larger wavelength. Okay, so the frequency going to be a larger wavelength. So it can go deep. It can go very deep. Okay, can go deep. Okay, low frequency you go deep. Okay, but less resolution. Less resolution. Less resolution means what? Not a proper scan. You might miss the stone. You might miss the stone. You want to detect the stone, the wavelength must hit the stone, then you detect the stone. Okay. So if the wavelength is very big, you might miss the stone. So using low frequency, you can go deep, but less resolution. Okay, less information. Okay, you need to scan carefully. Okay, but you want to go for if you go for high frequency, use high frequency, the wavelength is short, so the wavelength will be like this. So if there is the stone, you definitely can hit that stone. Okay, because better searching. So high frequency means more resolution. Okay, more resolution, but less depth. Okay, you can't go deep. You only can go less deep. Okay, that's the what do you call factor of frequency lah. Okay, so doctor will decide whether want to use a high frequency or low frequency. Okay, you want to check the organ which is quite close to the skin, maybe you go for high frequency to have a better resolution. And of course, intensity also, you can change the intensity. High intensity, amplitude going to be big, more energy, you can go deep. Okay, you want to go deep, and you have a more resolution, use high frequency, high intensity, but dangerous because it can heat up the tissue. Okay, yeah. Remember this. Low frequency, you can go deeper, but less resolution. Okay, less information about the body. So you need to scan a few times. More frequency, you get better, more resolution, better scanning, better searching. Smooth stone also can be detected by using high frequency, but you can't go deep because absorption is significant. Because absorption is found to be what? Proportional to the frequency of the sound. Higher the frequency, greater the absorption. Any questions? No questions. So sometimes you go to the first doctor, you say no stone. When you go to the next doctor, you say there is a stone. Okay, maybe the first doctor, when you go, he might use a low frequency what do you call scanning. He might miss the stone. Okay, so if a more experienced ultrasound scanners, the technician, you go for the low frequency first, then you might go for the high frequency check. Is there any? So the technical part must be good by the technicians. Any questions? No questions. Okay. So that's about factor affecting absorption. The density of the tissue, bone highest absorption, the frequency of the ultrasound. Higher the frequency, more absorption. Okay. Yes. So yeah, that is lower frequency, about 3.5 megahertz. Yeah, 350 kilohertz. It's used for deeper penetration. Higher frequency for superficial areas. High frequency use will give image better resolution. Okay. So you see here, the fluid appears black. Why appears black? Because majority has been penetrating. Only little has been reflected. Fluid never reflect that much, so it looks black. Black got two things, either it transmitted completely or absorbed. Bone also will look black. Okay, bone absorb most of the X-ray. If you have a bright one is majority has been reflected. Majority has been reflected. Like stomach layer, when stomach you go after skin, you have lots of air in your stomach. I think entire imaging going to be like white. Okay, because majority has been reflected white. So doctor will know. Doctor when he visualize it, you know which is soft tissue, which is the fetus head. So they know better. Okay. Okay. So now ultrasound got two type of scan. Okay, we're almost to the end of the topic. Okay, it got two type of scan, A scan and B scan. Okay, A scan, one dimension scan. You put an ultrasound, you go in depth, every boundary of the tissue, it will be reflected. So you have a peak, and this A scan, one dimension scan. Well, A scan only tell us how deep is the layers. Okay. So A scan are used to measure the distances, only to measure the distances. How deep is another layer? A transducer emit an ultrasonic pulse, and time taken for the pulse to bounce off an object and come back is graphed in order to determine how far away the object is. So A scan only give one dimensional. Remember, A scan is one dimensional scan. One dimensional scan. Therefore, it only used to tell the depth, only tell how deep is the layers. So A scan system measures the distance of the different boundaries from the transducer. Okay, transducer held in one position. Short burst ultrasound is transmitted to the body. Each boundary, some ultrasound will be reflected, some will be transmitted. The reflected pulse is picked up, amplified, and displayed. Okay. Okay, of course, some of energy reflected pulse to be lost. Energy is lost due to absorption. Okay. So consequently, echoes from deeper in the body tends to be lower intensity. the one coming from when to reach from so deep and come to the surface, then intensity definitely going to be very low. Okay. Yeah. So the vertical line appears each time as echo is received. Vertical line tells the boundary of the two borders. Okay. Okay. Next is B scan. Okay. B scan is a 2D view. It's a 2D view. A scan, the transducer only located at one location. B scan, we swipe the transducer around. We go from one point to another. So what the B scan does, it collects all the information of the A scan image. It combine, make a 2D layer. Now that's B scan. You see, B scan can be used to take an image of a cross section through the body. The transducer is swept across the area, and the time taken for pulse to return to is used to determine the distance, which are plotted as a series of dots on the image. A series of A scan image is combined to form a 2D view, which are plotted a series of dots on the image. B scan will give two-dimensional information about the cross section. So B scan better than A scan because it can give a two-dimensional information. The layers. Now I think all are B scan now. Okay. So A scan one dimension, 2 scan B dimension, 2D. A scan tells the depth of the tissue. B scan also tell the depth of the tissue, but in a 2D. Okay. So like this, you swipe around, so you will get a 2D image. A 2D image. The B scan technique combines a series of A scan taken from a range of different angles to form a two-dimensional picture. This is a very good term you need to remember. B scan technique basically combines a series of A scan imaging to form a two-dimensional picture. Okay, the example for B scan, a series of a small crystal, each having a slight different orientation. Okay, signal received from the crystal is each reflected pulse is shown as a bright spot, okay, on the screen of CR. Okay, so a 3D ultrasound. Okay, a 3D ultrasound. Now we got 3D. 3D ultrasound use the same principle of 2D. The sound are emitted from all angles. So you get 3D view now. Now the sound is emitted in different angles to form a 3D view. Okay. Now also we got 4D. 4D shows the movement. This is a 4D ultrasound. Okay, this is the what do you call this? The heart of a baby. A small baby in the growing. So they check the heartbeat. This is the what? The tricuspid and the bicuspid, the valve, right? So check how the valve works. So the ultrasound can really show that. This 4D image is actually a 3D, few 3D images run at a different time, but added in a time dimension. Displays a series of 3D images over a period of time, thus giving it the motion. Okay, few frames of images was combined to run in a time. The time is another fourth dimension. These are generally short clips and can show a heart beating of a baby, which is rounding. Okay, any questions so far?
Need to know what the 3D and 4D. What's the name of it?
3D standstill image.
Oh, standstill image.
Standstill, but it's like a 3D view. 4D, it will be moving. Few 3D movies
so
have
like
been combined.
C scan or D scan.
This all are B scan. This all are already B scan already.
Okay.
More than 2D is all are B scan already. Okay. Okay, next we're going to talk about advantages of ultrasound scanning. What is the advantage? What is the disadvantage you have to do? The advantage here we are comparing with X-ray, with X-ray. So as I said, too low level of scanning to high level of scanning. Okay, ultrasound and X-ray is compared, low level of scanning. The doctor before ask you to go for an MRI or CT scan, they'll test with the ultrasound or X-ray first. Okay, ultrasound can make ultrasound advantage is it can show soft tissues. Okay, soft tissues. X-ray normally go for bones. Bones you can't really show soft tissues. Can differentiate clearly between the solid and fluid filled spaces. Give instant image. Yes. X-ray, after you take the shot, you need to wait for a while, then you get the imaging. This one, instant image. When they put the transducer on your body, immediately you can see the scanning on the screen. Okay. So instant image. Okay. So yeah, allows for the structure of the organ to be detected as well as determine how the organ is functioning. Yeah. So for baby, actually, we can see how the function of the organs. You want to go scan the kidney, they check the kidney size, about 12 centimeter or something, and how the kidney shape looks like. Is there any stones inside? So they can monitor the function of the organs. Okay, just now you saw the heartbeat, how the valve works, all can be checked by using ultrasound. Okay. There are no side effect. Okay, that's one advantage of ultrasound. X-ray, radiation, but ultrasound, no side effect, no known side effect. Okay, and relatively very small. The size is like a computer, like a desktop, so you can carry into the ambulance. Okay, you can carry anywhere. You can put it into the ambulance. X-ray, definitely you can't put it in the ambulance. X-ray need a special room, lead coated room, because radiation. Of course, CT, MRI can't. It's quite big. Okay, so these are the advantages of ultrasound. Ultrasound, soft tissue can be investigated. No side effect. Size is small. Yeah, and can see the organs functioning. Okay, and of course, they can record it. They can give you a CD or the soft file for you to view. Although there is advantage, there is disadvantage also for ultrasound. One of the main disadvantages, it cannot penetrate bone. So you can't any cracks to your bone, you can't go for ultrasound. Ultrasound is a failure against bone. Can't scan bone. Okay. So when a gas exists between the device and the target organ, there is a lot of difficulty using ultrasound. This makes scanning of certain organs like pancreas almost impossible. A lot of gas. Because pancreas, I think, is behind the stomach. So normally a lot of gas, so difficult. So cannot penetrate deep into the body sometimes. So deep body difficult to scan. Kidney normally they scan from the back. Okay, they put the scanner at the back. They put a transducer at the back. Okay, to see the. But if the organ is just in between your stomach layer at the center, then sometimes difficult. So some concern about development of heat, increase their temperature locally. So heat rises, formation of bubble, cavitation happens. Okay, this is the weakness. The main weakness you can tell is cannot penetrate bone. Okay, if there is a gas layer, difficult to use organ ultrasound. Okay. So yes, so this is the end part of the topic. So we're done with ultrasound already. Okay. So what do you learn about ultrasound? First, you learn about how it works. Okay, how piezoelectric transistor works, emitting and receiving ultrasound. Okay, and how the imaging is formed, and how the calculation to be done, the absorption and the reflection. The absorption factor affected by what the coefficient of absorption is affected by what factor? Frequency of the signal, and also the type of tissue, the density of the tissue. Okay. Okay. So, but in a simplification, I tell you summary. This is why you need to remember for ultrasound. If they ask you to explain, like MRI last time, how MRI works, 8 marks of what do you call points, right? So ultrasound also has the same thing, about 6 marks. Explain the main principle behind the use of ultrasound. So you have to memorize this. Pulses of ultrasound reflected at every boundary. Okay, receive detected. Signal process and display. The time tells what? The time delay tells the time between the transmission and receive of pulse gives. Okay, time tells the depth of the pulse. Time between the transmission and receive tells the depth of the pulse. The intensity of the reflected intensity tells the nature of the boundary. It's made of what type of tissue. It's a big reflected intensity is so-called gas. Very little reflection, maybe it passed through bone, something like that. So these 6 marks. Ultrasound transmitted, partially reflected, received and detected. The signal is processed and displayed, already 4 marks. Time tells the depth of the boundary. Reflected intensity tells the nature of the boundary. What type of tissue made of. Okay, very important. Memorize this 6 marks for ultrasound. Like a summary. Okay, that day I think just now we did this question already. We go skip. Okay, more questions. This is November 7. State what is meant by acoustic impedance. So acoustic impedance is the product of density and speed of the sound. The product of density and speed of sound is the acoustic impedance. Explain why acoustic impedance is important when considering reflection ultrasound of the boundary between the two media. Yeah, the acoustic impedance determines how much will be reflected. Difference in acoustic impedance determines the fraction of incident intensity that will be reflected. So that's why acoustic impedance is important. A difference in acoustic impedance. Okay, 3. Explain the principle behind the ultrasound to the body. The same 6 points like the earlier one. You can tell. Repeat it again. What is the principle of use of ultrasound to obtain a diagnostic information? Pulse of ultrasound send reflected at boundaries, detected and processed. Time for return tells the depth. The reflection tells the intensity of the reflection tells the tissue structure. Okay. Okay. So another one question. You see the thickness X of the layer. Okay. Let's retry. Data for acoustic impedance for fat and muscle given. This is muscle. This is fat. The thickness of X of the layer of fat on an animal illustrated to be investigated using ultrasound. So ultrasound entering the fat. The thickness of fat is X. Okay, then the intensity of the parallel ultrasound beam entering the surface S of the layer fat is I. So it already entered the fat with I. The beam is reflected from the boundary between the fat and muscle, and the intensity reflected ultrasound detected at S 0.012 I. So they said what? The intensity inside here was I. Go and hit and bounces back again. This is the reflected intensity. How many I? Reflected one is found to be 0.012 I. So sorry, the one received back was 0.012 I. Okay. Okay, how this I and I related? I told you, right? So I equals to how many times absorption? Twice. So use what? E negative. They use mu. So you use mu lah. So you see given mu. So you put mu x. X should be how many x? X should be 2x lah, right? 2x. Why 2x? Because 2 times absorption. Then multiply by the here at the corner here at the boundary reflected. So alpha times alpha. Alpha of fat and muscle. Yeah. So this is the formula I use. Here should be I naught. I. But the I naught they put as I. But after that, how much of I? 0.012 I. So conclusion is 0.012 I equals to I E negative mu 2x multiplied by alpha. This is the equation must come to your mind. Okay. If you know alpha, you can work out the x. How thick is the fat? Okay, so that's the conclusion. Any questions? How do you find alpha? Alpha, you can get it from, alpha is what? The Z1 minus Z2 squared over Z1 plus Z2 squared. Normally they give the equation. They didn't give the equation. Yeah, so alpha is 0.018. Then you see the formula. This is the first question. The intensity reflection coefficient of the boundary alpha. So Z1 Z2 minus Z1, Z2 plus Z1. So you get 0.018. Means what? 1.8% has been reflected. Attenuation in fat. Attenuation. Next question. The thickness X of the layers. Yes, you can use the formula I just now tell you. 0.012 is the alpha. 0.018. Actually, both sides got I. I has been cancelled. Exponential 0.48 2x times 10 power negative 2. Why they put negative 2 here? Alpha is 0.08. Mu x. Mu is how much? Mu is 48. So mu they put 48. So we put here 48. Why times 10 power negative 2? 48 only, right? You put 48, then answer you'll get in terms of meter. Okay. They want to put it in centimeter. Centimeter 2x times. You need to put negative 2. The attenuation in fat is exponential negative 48 2x. Or the x they want it to be in centimeter. That's why I put 2x times 10 power negative 2. So you get in centimeter. If you want it in meter, don't need to put negative 2. Okay, guys, got the idea? So this is the common question. They'll tell you go to the layer, reflected, bounce back, 2 times absorption, 1 time reflection. So make the equation. Any questions? Okay. So yeah, another one. So state what is meant by acoustic impedance of a medium. So what is acoustic impedance? It's the product of density and the speed of sound in that medium. So second one, part 2, the data for speed of ultrasound in that medium given, acoustic impedance is given. So again, the same story. The parabeam ultrasound I incident right angle to the boundary between the media. So incident intensity goes into the boundary, partially transmitted, partially reflected. Acoustic impedance for one is Z1, Z2. Oh, this question is slightly different. The media of acoustic Z1, Z2, the transmitted intensity of the ultrasound is IT and IR. State relation between IT, IR. So we know lah, I equals to IT plus IR, right? So IT plus IR. Okay. Okay, next to the reflection coefficient alpha is given. Find the gel and soft tissue. What is the alpha? Just substitute the gel, soft tissue Z lah. Gel and soft tissue Z is given. This acoustic impedance. Put in, you get the alpha and add to soft tissue. So yeah, so gel to soft tissue is found to be 0.001. Means what? Majority reflected or transmitted? Majority will be transmitted. Okay, the add to soft tissue alpha is 1. That means I think 100% reflected. That's why add to soft tissue. Air and soft tissue. Soft tissue go to air or add to soft tissue. Majority will be reflected. That's why if your stomach got air, majority will be reflected because alpha is huge. Coefficient of reflection between that boundary is huge. Okay. This is part B. Part C question is missing. Part C question: very little transmission of air skin boundary, complete transmission of gel skin boundary when wave travel in or out of the body. Maybe the question they ask: why gel is need to be used between the transducer and the skin? So this is the reason, because if you never use, majority will be reflected. Very little transmission of air skin boundary, so complete transmission of gel skin boundary happens when was travel from in and out of the body. That's why gel is used. Okay, that's all for ultrasound. Hey guys, any questions? So no questions, Okay, so this is one medical. Is this the wave? It's a wave question, ultrasound. How frequent ultrasound comes out? Not that frequent. Okay, maybe 2 years once. Maybe you get ultrasound. Okay, so if you are up to you, it comes out. It's going to be like a 6 marks question, 5 to 6 marks. Maybe. Okay, so yeah, it's optional topic. Okay, any questions? So we're done with all the learning outcome already. Any questions, guys? No questions, Okay, I don't want to start the next topic today.
I have a question.
Yeah.
Thin layer of silver, right?
Yeah, silver.
For the silicon atoms. Actually,
Yeah.
the force, when the what's it called the transducer probe is on the skin, right? Does the force produce current, or do we need some current first so that there is a difference in current?
Hold on. When you use transducer, the transducer connected to a current source, inside.
Oh, so that means
So
that
the current source, yeah, the
so
current source is already there.
So that means unstressed silicon,
Yeah.
is when it is off, is it?
When it off, yeah.
So when it's on, is it extended or compressed?
When it's on, the type of current you're going to give, the type of voltage, the type of voltage you're going to give is alternating voltage.
Alternating. So that means
so the crystals start to oscillate.
Oscillate, but is that after when I am putting it on the skin or before? Oh,
No. Once when they put on the skin, they on the transducer already. That means ultrasound already started.
So that means if it's on, but I haven't put it on my skin yet, it's just unstressed, is it?
No. Once you start the transducer, switch on the transducer,
Yes.
the ultrasound is already emitting.
Okay.
It's just a type of sound, right? It's not harmful. You
So that
won't
means
set
if there is no stress, that means the frequency is constant.
frequency is constant. So once you send the alternating voltage, the crystal start to oscillating continuously. Continuously oscillate produces the ultrasound.
So that means due to the difference in the frequency after I put it on my skin, that produces the image later on.
Yeah. Okay. So yeah. So the crystal. Any other questions? Okay, guys. So today I think I stopped early. Any questions? The next class we will continue with the last topic, telecommunication. Tomorrow you don't need to go to the college, right?
No.
So your lab is all, done by last week already. So tomorrow we will be like having a theory class. Okay. So 11 to 1. Okay. So we start with the last topic. Hope I can finish the last topic by hopefully next Wednesday. Okay. Then maybe Thursday and Friday, maybe we can do one paper at least before your trial. Okay. So I believe at the background you are doing the trial papers, past years, everything. Okay. And another one thing, continue to do your design papers, your design questions. The design questions, all answers here. Try to be prepared for your design, and the analytic part. The analysis part is always like a rigid question. Drawing best field line, worst field line, and finally find the gradient. Okay, and intercept, and some further questions after that. Okay. Okay. So, any questions? No questions. Okay. After telecommunication, you can see there is a definition list, part 1, part 2, definitions list for you to remember. Okay. So remember all the definitions before your exam. Okay. Okay, guys. So I stop here today.